during my studies at Stanford. So I have a degree from Stanford. I'm very happy for any connection with California again. Okay, so something happened to the screen. Can you see my presentation, or is it sort of stuck again?
We can see your presentation.
Okay, because I got the message of the recording here, so we sort of screwed things up. Okay, so in a couple of words, I'll just say that the Chief Scientist Unit, which I had, is mainly oriented to support the R&D for the purpose of furthering the Israeli economy, and also for the purpose of improving the energy market in Israel. In addition, we also deal with policy issues. Long-term, generally, we support the ministry in long-term policy, data-driven policy. And in recent years, we have actually taken a very significant part in decision-making in the ministry. Our budget is approximately, depending what you count, $15 to $20 million per year, and it's split between several programs. We support industrial research in pilot stage, later stage, also in startup stage. We support academic research, so these are even earlier, applicative research in the academia. And the US-Israel collaboration through the Bird Energy and the Energy Center is also a significant chunk of our budget. Our European collaboration is hidden within the rest. It's not separated in this chunk, so it's hidden within the rest of this pie. The situation in terms of renewable energy in Israel, these are the most recent numbers that we have, is that we have about 2,500 megawatts of installed renewable energy, which is almost exclusively solar energy, almost exclusively PV. We do have two CSP solar heat plants, which are 120 megawatts each. But in recent years, of course, only PV was installed. In the last couple of years, 2019 and 20, we have seen installations of approximately 600 megawatts. In terms of overall energy, by 2020, we were at approximately a little over 7% of solar in our electricity generation. The challenges for no, why doesn't it move? Okay. So the challenge is to increase this percentage. Starting in 2017, the push is quite strong. At first, for a goal of 10%, which was set back in 2009, actually, by the government. And we made quite strong efforts to reach it by 2020. We've not quite made it, but we do believe part of it was the Corona pandemic, which caused some delays, but not completely. So we are hoping that this year we will reach the 10% target. We have quite a lot of PV on rooftops. Almost 1,000 megawatts out of the 2,500 is actually on rooftops or dual use of some sort. We've seen the numbers for 2019. The rest of the energy in Israel currently, other than the 7% of the renewables, is 65% natural gas and a little less than 30% coal, which we are in the stage of phasing out. We've declared that we will phase out all of the coal power plants by the end of 2025. I would say that this is quite an impressive feat, taking into account that coal was 60% of the electricity generation in 2015. So really a very strong push to reduce the pollution that was initiated by our minister. This is sort of the effect of the current policy and what we expect to see by 2030, or if you will, actually by 2026, once we close the coal power plants. We can see already about 50% reduction in particles and NOxes in electricity generation. In terms of SO2, 70% already since 2014. And we expect to have by 2030 a negligible amount of NOxes. And in terms of emissions, CO2 emissions, we count it here in this graph as CO2 per kilowatt hour. Because Israel is constantly growing by quite a significant percentage. Our population growth is about 1.8% per year. So it is a little difficult to keep the overall numbers overall emissions impressive in terms of the reduction. So, but per kilowatt hour, the reduction will be significant. We have started a new era, if you want. At the end of 2020, the government decided to increase the goal to 2030 to 30% renewables in electricity generation, with a midterm goal of 20% by 2025. We are putting a strong effort, as I said, on the dual use. And we see quite low numbers, I think, compared to the rest of the world for dual use. The most recent dual use, which is mostly large rooftops and water reservoirs, came out at 18 agorot, which is about $5 per kilowatt hour. Also, a very low number we received in recent tenders for photovoltaics plus storage, 4 hours of storage. The most recent one came out at about 0.175, which is about the same as the rooftops, which means this is the average for the all the hours of production from a field which has photovoltaics plus 4 hours of storage. Again, this is a very low number in comparison to the rest of the world. And we certainly think this is something that will push the renewable era here in Israel forward. This is just I will just mention that in terms of just the pure fields, the numbers in Israel are not so low, but the lowest bid came out at 9 agorot per kilowatt hour for a ground-mounted PV field. If we look to 2030 and we're thinking, what do we need to do to reach this 30% goal by 2030? Then first of all, if we compare the previous target of 17% renewables by 2030 with the 30%, we see that on the left-hand side, the required fossil generation will not change at all. It means that the capacity credit, if you want, is very low for the solar because it's intermittent, and we cannot rely on it in the winter. So we have to keep all of our fossil generation in place for the 1 week or 2 weeks in the winter where there is not going to be enough solar. So this is one interesting thing that we need to think as we go along with higher and higher penetration, what we do with that, because we have to keep our fossil legacy all the time, and actually we'll need to increase it as the electricity consumption increases with the years and with the growing population. On the other hand, we can see that if we compare with and without storage, just the additional generation that we need to install, then if we add the storage, then we can take a significant dent in the additional fossil generation that will need to be installed by 2030. And essentially the batteries can take almost all of the extra fossil generation. I will skip the advantages due to lack of time, but I will mention a few interesting turning points for renewable energy. One is when solar energy becomes cheaper than the operating and running costs of gas. We are actually already at this point, meaning that it is cheaper to buy electricity from solar fields than just to run the gas generation, not even taking capital costs. This means basically that the system wants as much as much solar generation as possible on one hand, and the gas suppliers, they need to build a new business model where they will mostly be there as a standby and not be running and generating electricity much of the time. This is a big change, I think. Storage, one storage, as I mentioned, 4 hours on large fields, but the home storage is going to be the next big thing. Home storage today is high cost, but I expect it to get cheaper and cheaper quite quickly, as we are basically, it's electronics, and we have seen most of the industrialization of electronics bring extremely low prices very quickly. And I expect to see the batteries for home storage also going down very much. This will mean, and there is one example in Israel already where it sort of makes sense. It's called kosher electricity. People are willing to pay for the kosher electricity on Saturday, quite high prices. The other turning point is, of course, the EVs, and they carry a lot of storage with them. EVs will be a big player. I will run forward and mention now the problems that we're having. One, of course, is the intermittency. It's not available all the time. We need to find a way to smooth the generation of the renewables. It causes the ramp up, ramp down issues that California is well aware of course, and we will see that in Israel also very, very soon. The backup issue I already mentioned, the need to keep all the fossil generation, essentially almost all the fossil generation all the time, because the minimum renewable generation is very, very low in some days in the winter and even consecutive days.
Gideon, I apologize, but we are getting really short on time, and I hate to do that in a brutal way.
Give me a couple of minutes, I will sort of try to wrap up.
Thank you.
The area is a big issue now. The land that is needed to generate electricity from the sun is very large, and I will sort of end with the question mark here. Just I'll give you some numbers. Okay, if we look at to the year 2050, where we want to have a very high percentage of renewables, then we will probably generate then between 150 and 200 terawatt hours of electricity. To generate such electricity from solar, we can do the calculation. Each 1,000 megawatts generates in Israel about 1.7 terawatt hours of electricity. So we will need approximately 100 gigawatts of solar compared to what I said we have currently 2.5 gigawatts. And this translates to about 1,000 kilometers squared. And the whole of the Negev of Israel is 13,000. So this is a huge area that we are struggling to find where we do it, how we do the dual use. And currently with the focus of the water reservoirs, but they will be exhausted very quickly. And the next big thing, as far as we can tell, is the agriculture. We are looking into doing agriculture along with photovoltaics. And I will quit now. Thank you.
Thank you so much, Gideon, for this presentation. We do have 2 questions for you in the chat box. I will appreciate it if you can answer them during the next presentation.